Lydia Vitkova. I'm the senior analyst from Gazprom Net Oil Service, and we'll speak about user behavior, user and entity behavior analysis. And it's nice that you listened to the previous presentation, that we'd continue this topic. This title you can see on the screen. But let's just start this. We'll split this into a few parts, the blocks which may not be related, but I'll try to make sure that it's clear. First of all, we'll speak about UEBA, user behavior analysis. Then we'll speak about the questions which we see in CyberSec, compromised accounts, leakages, insiders, our people, all our infrastructure. And then we'll speak about extended analysis, and we'll speak about the digital shadow and how we use this. And then we'll make a summary. So, first of all, I should say that we are not supposed to read it in Russian, in the Russian pronunciation. It's an acronym. UEBA stands for foreign set of words. That's user and entity behavior analysis. I like this definition. In Kaspersky Labs, GigaChat is not an expert yet. It thinks that it's a bank system, or either we analyze the behavior of users, but that's the user and entity behavior analysis to protect our infrastructure. If we take the systems that we already have and they exist and are implemented in our protection, then we should mention that there should be two groups of them. The first group being directed at using behavior analysis as an embedded component, and it's just an algorithm, a method that tackles something, regardless whether it's a SIM, behavior analysis, sandbox. We check and verify the malware code and its dynamics. The other group of systems is developed in a way that it monitors the data leaks. In the market here, we have companies in Russia, like we are UEBA. We stand for UEBA products, and everyone points out that it's a certain data analysis which is user-centered. What we develop in our company, what we use in our company is a different method, and we would like you to join us as well. So we do it a little bit differently. So I repeat, there is some basic analysis, and we have some baseline, new rare action, etc., etc. Everything works. For instance, a user normally connects at 9 o'clock and then it disconnects at 6 p.m. using the same device, using the same login, and we believe that that's this user there. But then all of a sudden this user connects in an unexpected time. It's an unusual event, and the system creates an alert there, pointing out to a violation. We expand the user to any service or essence. We have standard behavior for services, for microservice architecture, for processes in the operating system on the kernel basis. And we can actually check for different entities. We can, of course, set the boundaries and frames, but why would we say that behavior analysis stops there, limits there? Because once we start analyzing everything and all, we immediately face with a huge amount of data. The DLP system, the other things that we have to work with, we have web resources. If we take all this massive data from there, if we take it in one cauldron, we'll result with nothing. So we need to have expanded analysis. We need to use the multiple data analysis. We have quite a lot of sensors, for example. They are connected to computer-aided design systems, and we just need to analyze the variations and check for their dependencies. And we are limited capacity-wise, computer performance-wise, we are limited. That's what limits our capabilities. But now I've just mentioned the UEBA as an acronym and what it stands for, what it means, and now we just need to address the problems. For this keynote, I've just selected some of them. So it's been all over the place, all over the news, and yesterday we mentioned that as well. So we'll speak about insiders and the compromised accounts. So we'll start with the compromises. What's so interesting here? So if we compare the number of reports in the channels where the information spreads for 2021 and 2022, we'd see that in 2022 we increased the number of leakages reports by 56 times. We excluded everything which is not related to the Russian segments, and still the growth is 56 times. The number of compromised records and both users and services exceeds the number of Russia's population by 6 times. And we also have additional information that the time for incident investigation has also increased. And what makes it so painful? Seems like that we are all compromised. All of our clients, all our people are compromised. Whether it was us or not us connected to the system, we are unsure about that. And for example, we have an insider model which has been present in different presentations. Here's a malicious user who is about to commit the crime and determined to do that. But we also have careless users, and we have compromised users. We have the purposes of the attacks. For the insider is the data theft, espionage, and sabotage. I guess sabotage is where we have it. In 2022, we have such cases. We did have such cases. I mean, the cases of sabotage. So we took the insider model, where the insider was present as a physical person. So we need to combine them and call them an object together. So what I've marked here with purple is that the existing employees, the former employees, part-time employees, we added that as an entity. They may be as entities, they may be information exchange links added there. So we make this classification more abstract, temporary, regular, private, so they are varied by their discrete features, discrete characteristics. There may be a partner who is not having any access to the infrastructure, but may work with a web service. And we have trainees. Starting from this year, we're going to get quite a lot of trainees, but they are treated as insiders, as entities. This technology, these means, the entities may be damaged. Reputation may be damaged, assets may be damaged, but we have to somehow track this. We need to track this and make sure that we avoid the damage. Like I mentioned previously, in order to make sure that we see everything, in order to make sure that we don't have blind spots that we won't be able to cover, and we won't be able to see it thoroughly. We just need to take a more holistic look, but we cannot take a more holistic look because we are limited by our resources, and what we can observe is just white noise. So basically in 2022, it was that situation that became aggravated. But previously, Gas-Inform Service, the company that I represent, started developing gas analyzers. The result can be patented. So I'll be showing you some third-party examples. So I'm not disclosing the patent. I will be describing it in dreadful words. But if we just go back to mathematical analysis, linear, we mentioned the topological data analysis. Topological data analysis, TDP, it's called TDA. Topology analysis is very densely used in medicine and genetic research, and we also use this technology to create digital shadow. Some topology to analyze first. The dendrogram is the first one, and these diagrams represent the growth of breast cancer tumor. So the scientists wanted to determine the principles of growth of breast cancer tumor. It was a difficult thing to do. The dendrogram cannot get a clear classification out of a huge amount of data. But instead, if we use topology, on the right-hand side, you can see this yellow curve, yellow branch. That stands for breast cancer tumor, which is benign. But everything which goes up is less than 1%, and that classification is the actual discovery, where you can use a huge amount of data and find dependencies. That's the topological data analysis, and it is used in medicine, like I said, and due to using this method, we can estimate the consequences at a very early stage. The development started in 2014. In 2021, the article was published, to which I published the link at the previous slide. I removed all the formulas out of it in order not to explain this. I don't have enough time to explain them right now. So there's a data flow and preliminary data processing. We set the digital shadow out of it, and it's stored in the digital shadow database, and then we create a digital shadow there again, and that's what helps us tell whether it's that entity, whether it's that user that we need. We can build digital shadows in a different way. We can build this, and the topology will allow us to do so. So this is the digital shadow. That's the Betty curve. That's the persistence curve, and altogether they create the essence. I mean, not the essence, but the entity. Here we're showing you the normal time frame, the normal timeline, and if you visualize this, I'm showing you the timeline. Then we make a cloud of points for one timeline and for the other one, and we get the Betty curves and the persistence curves. So the digital shadow that's on the upper part is the template to identify the variations. As we find the variations and fluctuations, immediately we look for an incident among these fluctuations and variations. We work with the infrastructure as a whole, so we take notice through this topology analysis that has been skipped by all the other methods. That's what the UEBA actually works like. We have a platform for it, and it's on the left-hand side. That's where we manage the flows, that's the database, that's where the server, and we collect the data from the sources, and we do not limit it with our own ones, and we form the base for digital shadows. We check for the flows and servers and attacks, because attacks are also entities. If an attack is repeated, we'll create a digital shadow for any attack. And this is how we work. This is the functional scheme. Our team is split into 3 parts. Unit number 1 specializes in cyber tests. It's the cybernetic test site where attacks are repeated, new ones are created, multiple step attacks are deployed. Then we create it for those people who will do it for the operator, for the incident management incident, what kind of attack it was like, what kind of digital shadow it has. And we have a data science department, like most companies have. We are quite aware of that. And it's very difficult to be somewhere between cybersec and mathematics. Some people say it's obvious here. Other people say it's not obvious here, but it's obvious there. It's not so obvious. I don't understand the mathematicians when they say it's digital shadow. It's so obvious. Basically, some people have some work done, and the work they do is used and reworked by other people. We can, of course, do it, and we use the analyzer, the baselines, but we try to expand our vision and make our horizons a little bit further. The development team will connect the product, and it's tested in the product development phase. In 2022, the product was launched, it went into production, it works. It actually takes control of me. I can see myself there, and I think this is it. If you have questions, I'm ready to take them. As far as conclusions are, you can read them on the slide, but in the modern reality, without digital shadow, we cannot exist, because otherwise we have to have some baselines, and despite that we have them, we still have blind spots, and we need to have digital shadows. There are plenty of stacks. If we speak about digital shadows, when we developed our own library, and we developed that, and it's going through the registration, it's going through this patent phase, we need to make sure that we cannot constantly connect the libraries from the internet. We are an enclosed circuit, so we had to rewrite it from Python to some other language, programming language, to make sure it stays afloat, so to speak. Flow management, we use flow brokers. If we speak about the incident management, we have implemented MyTree. I would really want to show you some multi-step attacks, but it's hard to do. And actually, the test site, which creates all of the norms, has been deployed on the OpenStack. We have those scenarios running on Jenkins, and as a norm, for example, this quarter we have launched a bunch of norms, and those that run in parallel with ransomware. And in the enclosed segment, we just check the behavior of the ransomware. The ransomware also have a life cycle, the delivery stage, other stages. There are plenty of types of ransomware related to the services, when they connect to some services externally. User-wise, we have an algorithm which we develop, and we check how frequently this user distracts, how frequently the user distracts. They cannot avoid distraction. I mean, the users. If we take the statistics of Microsoft, which date back to 2014, the user sometimes switches 300 times between different processes within 1 hour. And if you see the distance between the switches, you can actually create this so-called hyper focus of any user. And when you come up at work, I'm finishing. So I repeat, you do the same. So that's what digital shadow is all about. So I think we have used all the time for questions, and I think this is it.